Before we do this review, I want you to know there will be no Zoom meeting tomorrow. Okay? No Zoom on 12/11. E-learners, your study guide has been uploaded to Focus, and probably after this review today, I will upload the quiz. I will not be here tomorrow. You guys that are here in class, you'll take the quiz in class like you normally do. You'll have a sub, but there will be no Zoom meeting tomorrow. And the study guide is available now, and the quiz will be available shortly. So with that, we need to review scientific notation today. Scientific notation, and we're going to say here that a number in scientific notation. Yes. Oh, man. All right. Sorry about that. A number in scientific notation is written as the product of two factors in the form a times 10 to the nth power. N is an integer. And 1 is less than or equal to A, which is less than 10. A times 10 to the nth. This A has to be greater than or equal to 1, and it's got to be less than 10. That means it cannot be negative, okay? It cannot be negative. It can't be less than 1. It can't be more than 10. It can't be 10, all right? It's got to be less than 10. It's got to be greater than or equal to 1. So some examples would be 8.3 times 10 to the third. 4.12 times 10 to the negative third. 7.1 times 10 to the second. All right, those are all examples of numbers written in scientific notation. Okay? And then not in scientific notation. Examples of numbers not in scientific notation. If you had negative 8.3 times 10 to the third, that's a no. You can't do that. Your A cannot be negative. You can't have 83 times 10 to the third, because this first number's got to be greater than or equal to 1 and less than 10. So this is a no as well. Got it? Yes. Like there? Okay. Something like 0.23 times 10 to the negative fourth. All right, again, this a value is too small, so this is not in scientific notation. That's a no as well. Let's see, what other no-nos? Here's a no. Here's a 3.5 times 100. All right, can't be that either. That's a no. This times needs to be 10, times 10 to a power. All right? Greater than or equal to 1, less than 10, times 10 raised to a power. Not times 100, not times 1,000, not times 1. Okay? Y'all remember that, hopefully? A little bit? Maybe? You do now? All right. All right, so next we're going to review writing it in scientific notation, then writing it in standard notation, and then we're going to order some values. So writing a number in scientific notation. So we are going to write in scientific notation. And let's see, what do we got here? We got 1,430,000. 1,430,000. Okay. This number right here, the decimal point is not written in this case. So it's implied that it is at the far right. Now, to write this number in scientific notation, you got to move that decimal point to the left so that the first number is between 1 and 10. And in this case, you would move this decimal to the left 1, 2, 3, 4, 5, 6 times. All right? 6 times. So this 1.43 million in scientific notation is 1.43 times 10. And since you move the decimal 6 places, it's times 10 to the 6th. Now, if this number that you start with is greater than 1, your power will always be positive. Okay? If the number you're starting with is greater than 1, when you write it in scientific notation, your power will be positive. If the number you start with is less than 1, like let's say we start with 0.00023, and you have to write it in scientific notation. This number that we're starting with is less than 1, so it has to have a negative power in scientific notation. So we're going to take this decimal again. We're going to move it. Now we're going to move it 1, 2, 3, 4 places. We're moving it 4 to the right. So in scientific notation, we've got a 2.3 times 10. And since we moved the decimal 4 places, we are 10 to the negative 4 power. If the number you start with is less than 1, then your power has to be negative. All right, if this is less than 1, power's got to be negative. If this number you start with is greater than 1, then this power's got to be positive. I know sometimes people, they move the decimal, but they can't remember if I move it right, what's the sign? If I move it left, what's the sign? If you just remember that if the number you start with is greater than 1, your power's got to be positive. If the number you start with is less than 1, your power's got to be negative. All right, then you're going to have some numbers written in scientific notation. You're going to have to write them in standard notation. So we're going to write in standard notation. So let's say we got 5.5 times 10 to the 6th. 5.5 times 10 to the 6th. You can use this rule we just talked about in reverse now. Since your number that's in scientific notation has a positive power, then in standard notation, it's got to be greater than 1. All right? So I take this first number, this 5.5, and I just write it right here without the decimal. And then I put my pencil where the decimal would go, or where it is right here. And now we're moving this decimal 6 places to the right. All right? This has a positive power. Our number's got to be greater than 1, so we're moving this decimal to the right. So we go on 1, 2, 3, 4, 5, 6. And then your fillers are zeros. And then you work backwards every 3 and you put a comma. All right? So that's easier to see here in red. Go backwards every 3 and put a comma. So there's your number in standard notation. .8 times 10 to the 4th. I'm taking my 38, I'm rewriting it without the decimal. I'm putting my pencil where the decimal goes, and I'm going to the right 4. 1, 2, 3, 4, adding a decimal. Filling in with zeros, and going backwards every 3 and putting a comma. 3.8 times 10 to the 4th, that's 38,000. .26 times 10 to the -5th. All right, so now I got a negative power. I know my number is going to be less than 1. So when I write this 426, I'm going to move way over here to the right. So I got my 426. I'm going to put my pencil where the decimal was, and I'm going to the left 5 places. So 1, 2, 3, 4, 5, new decimal. And I'm filling in these cavities with zeros. So we got 1, 2, 3, 4 zeros. Let's do one more. .923 times 10 to the -4th. Same process. We got a negative power, so we're going to have a number less than 1. So we're going to move over here, give ourselves some space. We're going to go 2, 9, 2, 3. Putting the pencil between the 2 and the 9, And we're going left 4. 1, 2, 3, 4. We're filling in with zeros. So there's our number in standard notation. Everybody good with that? Review, right? Okay. All right, and the last thing we're going to review here is ordering numbers in scientific notation. Okay, ordering numbers in scientific notation. When ordering in scientific notation, order by exponent first, then arrange same exponents by the value of A. All right, so when you're ordering them, you order the exponents first. Then, if two numbers have the same exponent, use the value of the A. All right, the value of the A. So we're going to order these from least to greatest. And we're ordering from least to greatest. We got 2.5 times 10 to the 7th. 2.1 times 10 to the 7th. 3.5 times 10 to the 6th. 3.6 times 10 to the 6th. All right, so we're going from least to greatest. If we're going from least to greatest, we want our smallest exponents first. So we got 2 numbers to the 6th power. So those 2 are going to go first. But since they're both to the 6th power, we're going to look at the A value. We're going least to greatest. So the smaller of the 2 10 to the 6th need to go first, which is the 3.5. So we go 3.5 times 10 to the 6th. Then we go 3.6 times 10 to the 6th. And we're done with those 2. Now we've got 2 with 10 to the 7th power. They're both to the 7th power. We're going least to greatest. So we look at the A values. We look at the 2.1 and the 2.5. Since the 2.1 is smaller, it goes next. So we got 2.1 times 10 to the 7th. So that's gone. It leaves 1 left. That's our 2.5 times 10 to the 7th. All right, and on your study guide, in your assignment, especially on your quiz, please pay extra special attention to this. Because one question might be least to greatest, and the very next question might be greatest to least. Okay? If we're going least to greatest, our powers should be increasing. If our powers are the same, our A values should be increasing. If we were going greatest to least, our powers should be descending, and our A values should be descending as well with corresponding same powers. Everybody good with that? Questions? Okay. You e-learners, you're excused. Your study guide is on focus. Your quiz will be there shortly. No Zoom meeting tomorrow. If you guys don't have any questions, I am going to end this meeting.